Let's go ahead and start 6.1 notes. Chapter 5, we had discrete random variables. So chapter 6 has continuous random variables. So a continuous random variable has infinitely many values and the collection of those values is not countable. So we could say a continuous random variable, all the values between 5 and 20. There's an infinite number of values because you could say 5.0001. You could say 12.2232, so there's an infinite number of values. Discrete was not like that. We could list out every single value whenever it's a discrete random variable. But continuous, we can't, so it's not countable. We are going to look back at normal distributions as well in chapter 6. So this is just to help you remember, a normal distribution has the bell shape, it's symmetrical, and it has this equation, which we do not actually use this equation in this class, thank goodness. But we always look at mean and standard deviation. So mean is mu, standard deviation is sigma. The result is a continuous probability distribution with a symmetric bell shape. So we are going to look at a normal CDF. So CDF stands for continuous distribution or density function, actually. We were talking about PDFs before, probability distribution function, probability density function. So we're doing continuous density function, or it could be distribution formula. So the density curve of a standard normal distribution is the graph of a continuous probability distribution that satisfies the following properties. So the properties are the area under the curve equals 1. And there is a correspondence between area and probability. So we're talking about a normal distribution. So remember, that's bell-shaped. And it's that symmetrical. So we're talking about the area under this curve. So you have the x-axis and then you have the bell-shaped curve. So the area inside this curve is 1. We are also going to look at if we have a uniform distribution. But let's see, 3 more properties of a standard normal distribution. So we know it's bell-shaped and symmetric. The mean is 0 and standard deviation is 1. So that's for a standard normal distribution. So let's go ahead and draw it. Where you have mu in the middle, and then standard deviation, you go above and below the mean using standard deviation, which we're going to look at that as z-score in a little bit. But everything under this curve represents the probability of getting that amount, which probability is going to equal 1, right? When you add up all the probabilities, you'll get 1. And what it's saying is that there's a correspondence between area and probability. So actually, area also equals 1 because it's talking about area under the curve. Probability and area will both equal 1. When we talk about uniform distribution, uniform means they're all the same. All probabilities are equal. They are spread evenly over the range of possibilities. And it's going to look like a rectangle. So if we have our x and y axis where x represents your continuous random variables, let's say from 0 to 10, and all the probabilities, draw this little rectangle, are going to add up. And basically, it's just a bunch of lines that make this rectangle. Mine doesn't look quite like a rectangle, but it is. So let's say all the probabilities, all the continuous random variables between 0 and 10, this whole area is going to have to equal 1 because area and probability are the same. So what we can actually do is if there's 10, y'all stay right here. If there are 10 continuous random variables, we're looking at all of them, the area is going to equal 1. We can actually find what this height is right here. Because area for a rectangle is length times width, or base times height. We know that the area is going to be 1. Our length is 10. We want to know what the width is, or what the probability of each random variable is. So we would actually solve this equation. So we'd actually divide by 10. So the width is 1/10, or we can write it as 0.1. 1/10. So we can put that right here, 0.1. So you look at what the range is. The range times, or the length times the width, has to equal 1 because 1 is the area under the curve, which is a rectangle here. Okay, let's go to the next page. So this explains what we just did. The area of the curve becomes 1 when we make its height equal to the value of 1 over the range. So if we have a different example, let's say this is everything from 0 to 5. We can find what the probability of each of these continuous random variables are, would be taking 1 and dividing by the range because the area has to equal 1. So on this one, this is between 5, right? So our range is 5, so it'd be 1 over 5, giving us 0.2, or 2/10. So the probability of each of those continuous random variables is 0.2 because the area equals 1. So we're going to solve some problems using this. Because the total area under the density curve is equal to 1, there's a correspondence between area and probability. To find the area, multiply the length or the range by the probability, right? The height. You can also put on here length times width. We're going to solve some application problems using this. Go ahead and read the problem to yourself. So if we look at this probability, the x-axis represents the class length. And it tells us right here, the lengths are uniformly distributed between 50 and 52. So that's our range. Any time between those is equally possible. And then the height would be 0.5. So see how this range would be 2, right? So 2, 1 over 2. That's how they got that 0.5. So Kim has a job interview. If the class runs longer than 51.5, she'll be late for the interview. What's probability she will be late? So we're going to say probability that x is greater than 51.5. So we're going to use this uniform graph right here. So anything from here on, so they already shaded it for us. This represents P, where x is greater than 51.5. So the way you find that area, which remember area probability are the same, they correspond to each other, you find the length or the range by the probability. So right here would represent 0.5. And the height is also 0.5. So length is 0.5, width is 0.5. So to find that probability or that area, you'd multiply 0.5 times 0.5, which gives us 0.25. Which we could have done this a little simpler. Look at this. How many sections do we have? 4 sections. One of those sections is shaded, so 1/4 or 0.25. Next question, what is the probability that today's class will be no longer than 51? So probability that x will be no longer than, so it's going to have to be less than or equal to 51. I'm going to do this in a different color. So you go to 51 and everything less than it. So this, I'm going to have to change colors because that's hard to read. So you'd find the area of that, which the length would be 1, and the height would be 0.5. 1 times 0.5. Yep. So the length was 1, the width was 0.5. When you multiply those, you get half. Or you can look at what proportion of the rectangle is shaded. Half of it's shaded. Okay, let's go to the next page. We're going to skip down to normal distribution. So this is the normal distribution curve where our mean is 0 and our standard deviation is 1. So this is a standard normal distribution, bell-shaped, symmetrical. The area under the curve is 1. We're going to look at z-scores. So it's been a while since we've seen that word before. But z-score, let's go ahead and write what it measures. It's going to measures the horizontal distance from the mean. And we're going to use the z-score to find the area under the curve. So let's say we want to find the area to the left of the curve, like this. This is a certain z-score. We are going to find area, which, remember, area is the same thing as saying the probability. This is a little bit more tricky because it's not just a rectangle. We can do length times width. We're going to use our table that I gave y'all, and we are also going to use the calculator to find it. So there's 2 ways for us to find the area under the curve. So I'm going to show you the table way first. So how to find probabilities when given z-scores. So we have the table, which this is our table. It has positive on one side, negative on the other. It gives the cumulative area from the left up to a vertical line above a specific value. Can only be used if standard normal distribution. You have a mean of 0, standard deviation of 1. You have a negative and a positive. So whenever you think about your normal distribution, this is mu, or your mean. Anything this way would be a positive. So let's say this is 2, a z-score of 2. On the left side would be a z-score of -2 because it's below. And we're looking at the area under the curve. So we're always going to be looking at from a specific line. So we would look at the positive side for that one, and we'd look at the negative for this one. And you're looking at from that line all the way left. All this area is what that will find. So it's close to 1, but it's never over 1 because the area is always going to equal altogether 1. So if it's this one, then it'd be, let's say it's a -2, it would be just this area. Then +2 would be all of that area. So this area is small. This area would be a lot bigger because it's more to the right. So let's talk about what z-score is. It's the distance along the horizontal scale of the normal distribution, I'm going to abbreviate, curve. And the area, which is also going to represent probability, is going to be the region under the curve. So before we get to the graphing calculator way, I want to show you how to use the table on some examples. So go ahead and turn over to example 1 real quick. If thermometers have an average or a mean reading of 0, so mu equals 0, and a standard deviation, so sigma equals 1, of 1 degree for freezing water, if one thermometer is randomly selected, find the probability that at the freezing point of water, the reading is less than 1.58. So it wants to know the probability that the reading x is less than 1.58. That's what we're looking for. Write it as an inequality. We're also going to draw this on the normal distribution curve. So we have mu, which is 0. And we want to know what the probability that x is less than 1.58. So that's considered your z-score. So 1, 2, so it's 1.58 would be right here. Because anything below 0 would be negative. So we're finding the area under the curve, everything less than 1.58. So it's all of that area. So when we look at our table, we're going to look at the positive side. See how this is like that? See how we put 0 in the same spot? Our z 1.58 is right here. So we are going to look for the z that is 1.58. So the way you're going to look at it, you're going to look for the 1.5, and then you want the 0.08, and that is the number you're looking for. So you're going to go down to 1.5, so it's right here, and then over to the 0.08. So it's right here. So 1.5, and then tack on the 0.08, 0.9429. So 0.9429. 0. So the probability is 0.9429. So it's 94%, basically, that probability. So it's a pretty high probability, which it's majority of the graph. All right, let's look at how to use the calculator now. Using a graphing calculator. So you need your calculator out. Go ahead and clear the memory on it, just so it's reset to how it's supposed to be. And let's follow the instructions. It says press second bars. And we are going to go to normal CDF. Remember how I was talking about continuous density function? Cumulative density function. Number 2. And then it gives you this. So if you're on the same calculator that I'm on, it starts it for you. If you have your own calculator, I don't know if yours does this. Does it, Matt?
Yeah, mine's good.
Okay, good. What do you think this means? Why does it say -1 E99? What does that mean? It's scientific notation. You would move your decimal over 99 spots. But it's like a -1, so it's a really, really big negative number. So this -1 E99 represents negative infinity, is what it represents. So then a positive 1 E99 would represent positive infinity. It says enter the two scores separated by columns, then parentheses. We can use this if we are plugging in a left and a right. So let's look over at this example. The furthest left, see how it says lower, or we could say left. We could say that this is negative 1 E99. This would be considered your lower. So then this would be considered your upper for the calculator. I'm going to write it over here. So I do upper 1.58. And then my mean and standard deviation are standard 0 and 1. Go down, hit paste, and enter. Check it out. It's the same answer. Yep. So the only thing we really need to know is when it's not just asking for the area to the left, it may ask for the area to the right or the area between two numbers. So we've got to know how to do that. So let's look at different notation. Probability of A is less than Z, less than B. This is representing a Z-score that is between A and B. So the way that they're setting this up, I probably should use the variable Z instead of X like I was doing. So we're actually going to change this to Z. Doesn't change anything. It's just the Z-score instead. So go ahead and change that. All right, and then probability that Z is greater than A means it's going to be to the right. Probability that the Z-score is greater than A. So between A and B is going to be like this, where you have A and B, and it's all the area between. Greater than A, let's say A is right here. So it's going to be anything above. And then less than A is going to be to the left. So I just have to pay attention to which inequality symbol they use. And the last little note on here says we're not going to worry about a distinction between less than or equal to or just less than. We're going to count these as the same. So don't worry about that. It's still going to be the same. All right, we're going to skip example 2 and move on. Let's look at the next problem. So how to find the area of the value above a particular z-score. We'll be able to use the calculator on this, but we can use the table as well. But basically, if you know that you want to find this area, the area to the right, we can actually do 1 minus area to the left. Because remember, probability and area all equal 1. So you can take this area, subtract it from 1. On the graphing calculator, though, you can do that your lower is going to be your z, while your upper, you can do as 1E99. So this is whenever you're going to, see how this would be like positive infinity, and this is whatever that z-score is. So your left or your lower is z, your upper is infinity, which we can represent as 1E99. So example 1, using thermometers from previous example. So we have the same example where you have the mean in the middle. But this one is find the probability that it reads above. So z is greater than negative 1.23. So when we draw the z on our graph, which side of the 0 will it be on? This negative 1.23. Which side of 0 will we go to? The left or the right? Left, yep. So negative 1.23. And we want to find the area that z is greater than. So which direction are we going to shade? To the right. So as you're doing your assignment, it's a good idea to draw these so that you get an idea of what it's looking like. So you have a better understanding of what area you're talking about. So you can make sure, does that make sense or not? Like if I got 0.23 as my answer, that wouldn't make sense because it's more than half. It should be closer to 0.8, don't you think? So this is going to be your lower, and then your upper is infinity, positive infinity, which we represent as 1E99. So let's go ahead and do the VARs, normal CDF. The lower is going to be negative 1.23. Then the upper is 1E99. So the E is right here at the comma. So do second comma 1E99. And then our same standard deviation and mean. So it equals 0.890. Let's round it. So it'd go up to 7.8907. We're going to round each of these to 4 decimal places. Okay, we're going to skip example 2 and do one last problem. Find the probability that the chosen thermometer reads between negative 2 degrees and 1.5 degrees. So draw your normal distribution with our mean in the middle. And we want to find the probability that it reads between. So probability, this is where you're going to do that compound inequality. Negative 2 is less than z is less than 1.5. Negative 2, 1.5. So it's everything between. So we can use our calculator. So our left will be negative 2, or our lower, and our upper will be 1.5. So the area between those two z-scores, 0.9104. Okay, so we are done with that for today.